everyone. In today's video, we're going to talk about solving real-world problems with trigonometry. You can think that here we're going to be solving some word problems, and doing this is going to help us get a better understanding of how trigonometry can be used in the real world. Now, every word problem is going to be different, so I can't tell you exactly how to solve every single one of them, but I can give you some tools on how to succeed. Always start by drawing a diagram. You want to label which angle is your right angle. You then want to label your sides, the hypotenuse, the opposite, and the adjacent. And then we're going to talk about which angle is the angle of reference, okay? Figure out what we're doing there. And finally, you need to ask yourself, what am I looking for? Am I looking for the side length, or am I looking for the angle? And then once you have that and you have your triangle, you can use your knowledge of solving triangles, either looking for unknown angles or looking for unknown sides, to find the answer. Now before we jump in, there's a little bit of terminology that I think we should be talking about here. You're going to see problems with the word angle of elevation and angle of depression. I want you to imagine that you're standing there and you looking straight ahead. This is called the horizontal because your head does not have an angle to it. If you look up at a plane, for example, you are looking at an angle of elevation because you had to elevate your head. You had to raise it in order to look at the plane. But if you see a cute dog on the sidewalk, you have to look down in order to get there. Okay, we are having to look down, which means you're looking at an angle of depression. Think you're sad, and that's why your head is down. Okay, looking up is an angle of elevation. Looking down is an angle of depression. Okay, sometimes you might have problems that use these, and it's important that you understand. Let's just draw another diagram here. Imagine I'm walking on the sidewalk, and there is a bird. Okay, here's my sidewalk. Here's the bird. I am looking up at the bird. Therefore, I have an angle of elevation. The bird, however, is looking straight ahead. And so in order to look for me, the bird has to look down. But notice how if I wanted to finish off my triangle here, I already have two sides of a triangle. I have the ground, I have my angle looking up, I also have, let's say that's the height of the bird above the ground. Now if I'm given the information about the angle of elevation, that's great because my angle is inside my triangle. But imagine you were given the depression here. That is outside of the triangle. And so what we need to do is to figure out what the corresponding angle for inside the triangle actually is. Because we need our angles to be inside our triangle. In order to do that, we need to remember that this is a right angle and that those two are going to add up to 90 degrees. And so if you're looking for the question mark angle is going to be equal to 90 minus the angle of the depression. Okay? That is how you can convert, or you can move that information to be inside your triangle. Remember, if we started with the angle of elevation here, it's no problem because it's already inside the triangle. But the problem with the angle of the depression is that it was outside of the triangle, and so we needed to find a way to move it in so that it would be inside the triangle. And that's how we do this. Okay? Let's take a look at our first example. You are a lifeguard looking down at a swimmer in a pool. Your line of sight forms a 55-degree angle of depression. You are 10 feet up in your seat. How far is the swimmer from the base of your lifeguard stand? Well, let's go ahead and let's draw a diagram here. That's always the first step. So here's me. I got my hat on. It's a sunny day. I'm watching people swimming. I'm in a lifeguard stand. And we know that the lifeguard stand is 10 feet up in the air. Below is the pool. And there's a dude swimming in the pool. I'm looking down at this guy. It's a 55 angle of depression. I am looking down. Depression is what told me that I was looking down. Now, just like in this diagram here, the depression, remember, if I was looking straight out and then looking down, the looking down part would come here at 55 degrees. But 55 degrees is useless to me because it is outside of my triangle. I need to figure out what the distance is, or what the angle is inside my triangle. And so in order to find this information, I need to do 90 minus 55 degrees. That's going to give me the angle inside. 90 minus 55 is 35. So I now know that the angle inside here is 35 degrees. Finally, the question is asking, how far is the swimmer from the base of your lifeguard stand? So here's the base of my lifeguard stand. Here's the swimmer. There is my unknown. That is what I am looking for. Okay, now that I have a diagram, I can see pretty clearly what's happening, and I can start doing some math. First things first, I'm going to label my triangle with all of the with the three sides: hypotenuse, opposite, and adjacent. I can see pretty clearly that this side is going to be my hypotenuse because it is across from the right angle. This is my angle of interest, and therefore this side is going to be my opposite side because it is opposite the angle of interest. And finally, the 10, the height of the lifeguard stand, is going to be the adjacent because it is beside my 35 degree angle. So I have my hypotenuse, I have my opposite, and I have my adjacent. I also know that I'm looking for the length of the side, And we know with problems like that, we start off with an angle, and we start off with a side, and we need to figure out from there what is the third side. In order to do that, I need to pick my ratio first. I need to decide sine, cosine, or tangent. In this case, I need to pick tangent because tangent has both my unknown and it has my known. It has my unknown and it has my known. So I'm going to set up tangent is opposite over adjacent. Now let's fill in some information here. Tan of my angle, which is 35, is equal to x divided by 10. Now I can go ahead and I can type in tan into my calculator. Tan 35 gives me 0.7. And then I can multiply both sides by 10 in order to get x on its own. These 10s cancel out. 10 times 0.7 is 7. So 7 is equal to x. Because this is a word problem, I'm going to finish with a therefore statement to answer my question. So the question was, how far is the swimmer from the base of your lifeguard stand? So I can say, therefore, the swimmer is 7 feet from the base of my lifeguard stand. Okay, the problem's all done. So remember, we started off by drawing a diagram and figuring out any information that we needed. We picked which ratio we needed to use, and then we solved just like we were used to doing. Let's do a second problem here. A tree 40 feet high casts a shadow 58 feet long. Find the measure of the angle of elevation to the sun. Okay, let's start by drawing our tree. Okay, we'll make it an apple tree. Okay, and we have a shadow here. But we were told that the tree is 40 feet high. And our shadow is 58 feet long. We can imagine that the sun is somewhere over here. And so I can finish off my triangle just like this. And we know that we are looking for the angle to the sun, which is going to be that angle there. I know my tree makes a right angle with its shadow, so I can finish off by drawing my right angle there. Okay, now that I have drawn my diagram, I can start labeling my sides. I'm going to label the side that is opposite to my angle. The 40 is opposite. The dotted line here, that is my hypotenuse. And the 58 is my adjacent because it's beside the angle and it's the one that's left over. Now I need to decide, okay, which piece of information, which ratio am I going to pick? Am I going to pick sine, cosine, or tan? And I didn't need to do any of this stuff where I converted and I brought the angle into the triangle because the angle is already inside my triangle, so we are good to go. Okay, I need to find a ratio that has both opposite and adjacent because those are the two pieces of information that I have, opposite and adjacent. And that ratio happens to be tan. So I'm going to pick tan is opposite over adjacent. Now I can fill in that information. I can say tan, well, tan of what angle? I don't know. Tan of theta is opposite, which is 40, divided by adjacent, which is 58. Now we're going to bring in our calculator. We need to figure out what this is as a decimal. 40 divided by 58. Well, let's round that to about 0.7, shall we? So we're going to do tan theta is 0.7. Now in order to get my theta, my angle on its own, I need to do the inverse. So I need to do tan inverse of both sides. Okay, so tan inverse of tan theta and tan inverse of 0.7. The tan inverse allows me to cancel out my tans, leaving me with just theta. And I have tan inverse of 0.7 left over. Now I'm going to use my calculator again. I press the second button in tan, and then I type my decimal, 0.7. And that gives me about 35 degrees. So theta is 35 degrees. And I can conclude by writing a therefore statement. I'm just going to write it to the right. I can say therefore the angle of elevation to the sun is about 35 degrees. Okay? And that's that. Once again, we drew our diagram. We labeled our opposite, hypotenuse, and adjacent. We picked our ratio. We set up the information that we needed. And then we were good to go. We just used our mathematical knowledge to solve. And that's all, folks. Good job.